All right, and welcome back to another session of AVR120. Today we're going to be going over how to implement some AI into the scene as well as bake a nav mesh into the scene so that the AI will be able to move around and then detect the player's presence and then go ahead and run some additional logic regarding that. So the first thing we're going to want to go ahead and do here is create what's called a state machine on our enemy object. And so what a state machine is essentially it is a way to determine what state the enemy will be in. So we're going to create three states. We're going to create essentially a patrolling state, which will be its base state, and that will be the state with which it kind of walks around and just kind of goes to different points in the scene. We'll have another state where it basically is going to detect, when it detects the player, it's going to run after the player. And then when it gets close enough to the player, it will do an attack state where that's what we have where the attack functionality will be. We're not going to have attack functionality set up. We're just going to set up really the patrolling and the chasing, and then the attack functionality is maybe something that you would be able to add and do some research on yourself there. Otherwise, we're just going to go ahead and kind of leave it as is. So we have a kind of a simple setup here where the enemy is just going to kind of chase and follow around the player. We're going to need to use Unity's built-in Unity built-in AI components, particularly the navigation agent, which is a component we'll add onto our enemy object, which will allow us to set up this um, AI, and then we'll go ahead and we'll need to download some additional components, which I've added to the Canvas site that Unity has provided, which will go ahead and give us some access to additional components we can add onto our game objects, which will further extend the functionality of the artificial intelligence that Unity has kind of built into their engine here. So the first thing we're gonna want to go ahead and do is go to the Unity asset store, and you're going to want to search for zombie. And you'll want to get this. There's one option for like a free zombie here, which was what we're going to go ahead and use. So if we click this kind of nice zombie model will pop up here, and you're going to want to go ahead and sign in, add it to your assets, and then open it in Unity. Go ahead and open it in the editor. And you'll see here that you have the option to import this. So we can go ahead and import this into the editor. It's going to give me an error because I've actually already imported this. So, but you'll want to download it and then import it, and you'll want to select everything in that import and then just click import there. So once we have the zombie project folder or folder in the scene here, we'll go ahead and go to prefabs. And we can actually go ahead and just drag the zombie into the scene here. And it'll appear in the hierarchy. You can double click to zoom in on the zombie. And then we're going to want to press R and kind of like scale it up from the center a little bit so it's kind of matching the player more or less. And then what you can go ahead and do is start to set up the script. So if we go onto the zombie and then we click add component, we're going to create a script called EnemyAI. And we'll create and add this script here. And so let's double click the script so that it opens up. And so now what we'll need to go ahead and do is to get some references to the nav mesh agent. And you'll notice that we're going to get an error. It's going to be underlined in red squiggly, and that's because we need to use a using statement, and it's Unity Engine .ai. We'll also need to create a public transform and get a reference to our player. And we'll also need layer masks to determine what the ground is, as well as what the player is. So we're going to say what is ground and what is player. We're going to need some variables for the patrolling state of the enemy. So if the enemy is in a so we'll need a walk point for the enemy to go to. We'll set this randomly so that it kind of randomly patrols around the scene based on that point it has. Um, we'll use a flag essentially, or a true-false statement here that essentially says that we will set when the walk point has been set. We can set this to true, and it will walk to its location, and then um, we'll go ahead and set it to false uh, when it no longer has a walk point. We'll also create a float, which will determine the range of the enemy from the walk point that we've set randomly. Finally, we'll create. Well, actually, not finally. Excuse me. But we're going to create some attacking variables here. We're going to create a public and a float, and this will be called time between attacks. This will be the cooldown between the enemy's attacks, and then a bool called already attacked that will determine if the enemy has already attacked or not. And then that will apply the time between attacks number. So we're also going to need to apply these states now. So or some variables to control the state. So we're going to create a public float, and we're going to create a sight range variable. We'll create a public float attack range variable, and we will do the same things for the sight range. So we'll create some booleans to see if the enemy is in the sight range of the player, or if the enemy is within the attack range of the player. We'll need to create an awake function here, and we'll need to set the player equal to, and we're going to go ahead and access the game object class and use the find method on it, which will find a game object, and we need to pass it a string, and it needs to be the exact string of what we have in the editor. And so we're going to use this to find our first person player. I'm going to pass in my first person player like this because that's what it's called in my editor. It may be called something different for yours, so just double check and make sure that your first person player it matches the exact word of your first person player or what it's called. And I'm going to give it the transform of my player. We'll go ahead and set the agent variable we created to the nav mesh that we have on the enemy. Excuse me, nav mesh agent. And that will be it for the references we're going to set in awake. And we're going to want to go ahead and create some additional functions underneath update. So we're going to create a private void and a patrolling function to control the patrolling state, what the logic for the patrolling state. We'll go ahead and create a private void um, chase player state. And we will create a private void attack player state. All right, so now that we have those states set up here, we'll go to our update. And this is going to go ahead and check for sight and attack range. And for player. So we'll say player in sight range. We'll set that equal to, and we're going to access the physics class in Unity. We're going to use the check sphere, which we kind of used for the ground check. But basically, this is going to create a returns true if there's any colliders overlapping the sphere defined by position, radius, and world coordinates. So this will kind of like generate a sphere from the enemy, and essentially anything that is in the side of that sphere we can use. In this case, our player will check against the player, and we can basically do some things. So this sphere will we'll use the check sphere, and we're going to give it the starting position of that sphere will be the enemy's position. So this game object's position. We will give it the sight range. That's the distance we want it to have. And then we will give it the what is player layer to check against. And so we'll need to put the player in that layer, which we will do later in the video. So we'll go ahead and also create a player in attack range. And actually, we will do the same thing. So I'm just going to get and copy this, and I'm going to paste it. And it will be the exact same thing, except instead of sight range here, this will be attack range. And that will determine if the player is in the attack range. And so if the player is within that range, if the player is not in sight range and the player is not in the attack range, we'll call the patrolling function. And so in the patrolling function here, we're going to actually need another function that's connected to it, and this is a function called search for walk point, or search walk point is what we'll call it. So now what we'll say is if the walk point has not been set, all right, so if walk point set is not equal to true, we will go ahead and call the search for walk point function. And so I'll just comment this. If agent does not have a walk point set, search for one. Okay. And then if the agent does have a walk point set, then we are going to access the agent. So the nav agent on the object that we've just created, and we're going to access the set destination method off of that nav mesh agent component. And the set destination sets or updates the destination, thus triggering the calculation for a new path. Okay, and we will pass it the walk point, and so that will create a we're going to create a walk point out. So this is erroring out because we don't really have a walk point set here. So let's go ahead and do the logic to actually create a randomized point on the map for the enemy to walk to. So here we'll say we're going to calculate a random point in a range to use to randomize the walk point location. So we'll create a float and call this random z and set it to random. So we'll access the random class.range, and that will give us a random number between the negative walk point range, all right, and the positive walk point range there. We'll also go ahead and do that for the x-axis. So we'll create float random x, and we'll set that equal to the same thing. And I'm actually, oops, excuse me, I'm going to go ahead and just copy this line, and I'm going to paste it down here, and we'll use the exact same thing there. So now we need to create the actual randomized walk point. So I'm just going to comment this out. I'm going to say random point on the map. And we'll go ahead and we'll create the walk point. Excuse me, not create, but we'll initialize the walk point variable to the new to a new vector 3, and that new vector 3 will be the transform.position.x. So the x part of the transform, remember transform is 3 rays, x, y, and z, so it's the x ray, and we will add the random x number that we've created to that to create a random x position for the walk point, so that that will be the random position on the horizontal axis for the enemy to traverse. We want to keep the y position the same as the enemy's current y, because we don't want him to go be flying, right? We don't want him to go up and down. He's walking. And then we'll go ahead and we will access his position on the z-axis or the z-axis, and we will add the random z value to that to randomize where he is going to be walking. And so just to finish this comment out, we'll say random point on the map, taking position of enemy and adding random values to it, so he will walk around randomly on the x and z axis of his transform, or of just x and z axis, because it's basically the random transform of the map. And then that will all work pretty well, but the last thing we need to do is make sure that he is not going to be kind of walking in a random spot that is outside of the bounds of the map and that is not on the ground. So we need to do a check using physics.raycast. And we need to pass it in the walk point that we just created. We need to pass it in the ground, essentially, or a downward transform. Okay. So we'll need to pass it a direction. So the walk point, essentially, we're giving it the walk point as the origin. We want to make sure that the walk point's down. It's not downward. It's not a downward direction from the walk point, because we're already taking care of his y here. So he's not going to be going up, but we need to make sure that he's not going down either. We also need to then give him a float, because that's going to be the max distance that he can go. We just want a static value there. And then we want to make sure that he's checking against what the ground is. So we're going to, the layer mask of the ground, make sure that he's checking that. And if all that is true, then we will set the walk point set equal to true. And so what this is going to do is, again, we're going to calculate these random values. We're going to create a walk point in the world space. We're going to give it that walk space is going to be the transforms position X of this game object, which is a zombie. We're going to add that random value to that. We're going to keep his Y the same, and we're going to create a random Z value. So it's going to be a random value on the map that he's going to walk to, and then this is just a check to make sure that his walk point is going to not be below the map, and that it's going to be on the ground. It's not going to be outside of the range of the map. And if all of this is true, we're going to set the walk point set to true. All right, and if we jump back up to the patrolling method, if the walk point is set to true, right, after we run down that function, then the agent's destination is going to be set to that walk point. Okay? So down here we'll say if everything in search walk point is true, then we will set the destination of the enemy to the walk point we just created. And this should actually be, excuse me, walk point set, because it's a we need to check to see if this is set. So if this is true, right, which we set to true here, if all of this works correctly, if this is true, then we set the destination of the enemy. We'll also need to go ahead and calculate the distance to the walk point so we can set that in the editor. So we'll go ahead and have a vector3 here, and we'll call this distance to walk point, and we will set it equal to the transforms dot position of the enemy, and we'll subtract the walk point from that. And we'll basically do a check using that. And we're not going to set that in the editor. We're just doing this, using it to do a check here. We'll say if the distance to walk point and the magnitude, so returns the length of this vector, so the length of the distance to walk point, okay, if that is less than 1, then we will set the walk point set to false. And what that will do is it will send us back up here, and we will go ahead and go back into search walk point again and set a random walk point. So it's kind of creating a loop here once it hits a certain distance from the actual walk point there. And so we'll say calculating distance to walk point. And then we'll say when the walk point reached, we're resetting the walk point. All right, so now that we've kind of created that logic, it's a lot of, a decent amount of code there. So good job trying, sticking with it. We'll go to the chase player method. And so this will get called, all right, if we go back up to update, we're going to want to call this essentially if the player is in sight range, but he is not in attack range. All right, that's when we will call the chase player function. And so we can actually click this, and if you right click and go to definition, it'll take us right down to where that method is. So the chase player method here, this is going to be a lot easier. All we're going to do is set the destination of the enemy to the player's position. And then so let's go back up to update here. We'll go ahead and the last thing we're going to do, we're going to say is if the player is in sight range and the player is in attack range, then we're going to go ahead and attack. Have the enemy attack. And so let's scroll down here. We will set the agent's destination. So we don't want him to move when he gets into the attack range. We don't want him to keep moving towards the player. So we're just going to set his destination to his current position. Stop him from moving. He's going to look at the player because we want him to be constantly looking at the player. So if you're like rotating around the enemy, he's still looking at you. And then we will say, we'll run a check and say if you've already attacked, if the enemy's already attacked, and then this is where we'll put our attack code. So I don't have the attack code here for now. That's something you can go ahead and research if that's something you're interested in. But for now, we will kind of leave it at it as is. One thing you could do is use the target kind of script that we created to, create a similar thing for the player health. And, if the enemy hits the player or hits within a certain trigger distance of the player, you can subtract the player's health. And then you probably would have to kind of sync up some animations, but we're not going to do that within the confines of this class. So, but we'll get this set up so that this is something, if you want to implement, you can kind of research it and do it on your own. So we'll just set already attacked equal to true at the bottom of this check here after the attack code runs is the idea. And then we'll want to go ahead and call the reset attack function. So we'll use this to basically set this bool to false so that it like reruns this code, this attack code here. And what we can do is use something called a Unity event. And a Unity event is basically a way to call a method and then have it run, and then basically kind of have it run um, at a certain time interval that we determine via a float, which we're going to essentially, the float that we're using is the time between attacks. So in order to create a Unity, to use the Unity event here, we're gonna use this invoke method, and that's gonna invoke the method between method name and time in seconds. All right, we're going to pass it the name of the method, and the method will be called reset attack, which we'll create in a second here. And then we'll put a comma, and we will give it the time between attacks, and that will be the float that will determine essentially when this reset attack occurs. And so now we'll go ahead and create a private void, and we'll create a reset attack function. And this function will set already attacked equal to false. And so this will essentially work. We'll say sets your true, ends attack code, and resets attack via reset attack method there. So now the last thing we want to do in the code here is we want to visualize essentially when we want to visualize when this is happening, and what this looks like from the enemy. So we can actually use something called private void on draw gizmos selected. So a gizmo is like something in the Unity editor, like for example, when you can kind of see the cameras, like the image that shows that would be a gizmo, or you can kind of make your own gizmos and tags to kind of be like label what happens. Like say if you have a trigger, you can use that and set that up in the editor. So we're not going to do any of that, but we are going to use the gizmos, and we're going to access its color field, and we're going to set the color field to red. And then we're going to again access the gizmos, and we're going to access the draw wire sphere method, and we're going to give it the transform of the enemy and then its attack range, and that will create a sphere from the enemy's position of the length of the essentially radius and size of the attack range. And then we'll go ahead and do the same thing, except we'll make the color yellow, and we will create another draw sphere here, draw wire sphere, access that method. We'll pass it the enemy's position, and this time we'll pass the sight range. Okay, so that was a lot of code. Go ahead and save everything here, and let's go back into the editor now. And we'll see we have a boatload of different fields that we need to fill in. But in addition to this, we need to also add some additional components as well. So on the website here, if we go to Canvas, all right, and we actually go to the file section here, I've added a nav mesh components section to the files. And so let's go into here, and then we'll want to download this zip. So you can just click it and download. And I'm going to show in folder and show it in my downloads folder. I've downloaded once, so it's got the one there. But you can double click the nav mesh. I have WinRAR, which is free, so it's pretty nice. I like it a little bit better than WinZip. But if you don't have WinRAR, you're gonna be presented with the WinZip. Unzip. You just need to basically find the file path of where you have the project. Okay, so a way to do that easily is if you go back to the project now, and in this project pane where the assets are, you can in empty space, if you right click and you click show in Explorer, that will tell you where your files are in your file explorer. So mine's in documents, Unity games, and then this folder here. So what I want to go ahead and do is I'm going to go to my downloads, and I'm just going to double click. I'm going to extract this into my documents and my Unity games folder. I have a lot, obviously. I'm going to click the folder that my game is in. So it's FPS AVR120 to 2022. It's that one there. So, and then I want to actually extract it into the assets folder, the top level assets folder itself. So make sure that you're selecting the assets folder to unzip it to. And if it's not there, just move the folder into assets there. All right. So now that we've got that in here, if we take a look, we'll get presented with this kind of consent. Just go ahead and press yes for all of it. And now we've had the nav mesh components added there in our assets. And if you don't download things from the package manager, that's like one way to get your files into your assets is to just drag a folder into the assets via your file explorer or even in while the game Unity is open. So now we'll need to go ahead and we need to add the nav mesh agent to the zombie object here. And this agent here, if we click this, it's going to take that zombie object. It's getting the nav mesh. It's getting this essentially. It's the same as dragging this into that little slot there. We're getting a reference to that. We also need a reference to the player. So we'll need to go to the first person player in the hierarchy and drag that where the player option is. We need to put the player on a player layer. So I actually already have it on a layer, but if you don't, you're going to want to go ahead and go to add layer, and then just select the layer you want to put the object on. You'll enter it, click the object again. So click the FPS player again, and then set the layer at the top right hand corner here from play to it should be like default. Just set it from default to player, and you'll want to yes, change all children. So then once you do that, go back to the zombie, and we want to set what is ground. We want to set that to the ground, which we set that layer up in an earlier video, but just you want to select all of your ground units and do the same thing we just did for player except for ground. And then we want to set what is player equal to player. Walk point range, I'm going to put this to 15. I want it to be a fairly big number. Time between attacks is like 2. And then sight range is going to be something like 10. And we can see when I do that, that actually gives us like a wireframe that is the sight range of the enemy. And so if the player gets in that sight range, it'll activate chase. Otherwise, it'll just do patrol, which will create a random walk point. And then I'll make the attack range like 4. So like once the player gets within the attack range, the enemy will just stop, so it doesn't like keep running through the player or running to some random place. And then he'll. The idea would be you'd have like an attack animation, and then you'd also just when the player is within that sphere, it would deal damage. So the last thing in order to get this to work that we're going to need to add is the nav mesh component to the scene. So a nav mesh basically will determine where the enemy is able to go ahead and walk around. So we've downloaded these nav mesh components. And the reason we did that is so that we could have access to this nav mesh and add it to our scene. So we'll go ahead in the hierarchy, we'll right click and we'll create an empty game object. And on that empty game object, we'll just add a component and we will search for the nav mesh surface. And so we don't really need to change much of anything on here, and we'll just go ahead and press the bake button. And now we'll see that all the stuff that's in blue is the space with which the enemy can traverse, and so like we can't traverse around these trees, but he can traverse up the stairs and the building and yada yada yada. So it works kind of like that. So now if we go ahead and we'll go back to the enemy, looks like everything is set pretty well, so we'll go ahead and press play. And now we can see here that the enemy is kind of just walking around. And when we get within the range of the enemy, he'll start kind of moving more towards us here. And then when he gets within our range, he will stop. So he's just kind of playing an animation cycle now, but so that's the general gist of it. It can be elaborated on quite a bit more, but I just wanted to show you guys the nav mesh and some simple AI that we've set up here. And that will pretty much do it for this session and actually the class. So I just want to thank you guys for following along. Really enjoyed your projects. And if you have any other questions, feel free to let me know. Shoot me an email. And thanks so much and have a great rest of your day.